Hi everyone, I am Rebecca from ChemKnits, and today I'm here with, I suppose, part 3 of the math of yarn dyeing. But this time we're going to be talking about food coloring and how you could do some calculations with it in a similar but different way from what we did in Dyepot Weekly 117. Before I get into the demonstration, I need to remind you that food coloring is not designed with dyeing fiber in mind. And so therefore, there really aren't specifications and recommendations from the dye company for the OWG, or on weight of goods. Companies such as Dharma and Jacquard and other commercial dye companies will frequently recommend anywhere from, with acid dyes, between a 1% or 4% on weight of goods when you want to dye a particular shade that they say they're providing. The on weight of goods is 1 gram of dye per 100 grams of fiber. But when we're looking at food coloring, the food coloring isn't coming as a powder. It's coming either in a gel paste or a liquid form. I mean, technically you can buy food coloring as a powder, but I'm sort of pushing that to the side for today's video. So previously, when I was doing a stock solution with the powdered dye, you really want to make sure you mix it so that way it can all be in solution so you can get as even of a color as you want. With food coloring, it's pretty instantaneous to mix a liquid drop of food coloring in some water. And it's also pretty quick and easy to mix a gel food coloring like Wilton's Icing color in water as well. So I'm not going to be mixing, say, a 1% stock solution. I will be mixing a solution today, but I'm going to sort of refer to it as the concentration that it is in terms of the volume of gel icing color that I measure per total volume of my stock solution. So I suppose I do have a depth of shade that I prefer with my Wilton's Violet food coloring. I like using 1/2 teaspoon of Wilton's Violet per 100 grams of yarn. And this proportion of the icing color to fiber does vary based on the color. Creamy peach is a lot less saturated, black is a lot more saturated, so I use less black, I use a lot more creamy peach. In today's video, we are going to dye 5 20-gram miniskeins of 75% superwash merino, 25% nylon yarn from Wool to Dye For. And we're going to be doing this at with different amounts of Wilton's Violet food coloring. So you can see a difference in, I'm a little hesitant to say depth of shade because that has sort of like a clear industry definition, but we will be looking at different levels of saturation of the color. I think what's most important here is that as long as you define your stock solution and your concentrations consistently, then you can go through and say, okay, I want a paler shade, or I want a more intense shade. And you can go ahead and calculate how much of the color you need to achieve the results you want. Finally, one big argument for not making a huge stock solution of Wilton's Violet food coloring and sort of leaving it and going back into it is that the red number 3 isn't as stable in solution over time. With a little bit of acid, it'll start crashing out, which will affect your color. I believe that this is a big reason why you don't see red number 3 in a lot of commercial beverages. Just go through the supermarket and check out all the colors of Gatorade. You'll see red 40, not red number 3. But anyway, let's go have some fun with food coloring. As I said, my favorite proportion with specifically the Wilton's Violet food coloring is to use 1/2 teaspoon of the gel icing color per 100 grams of fiber. And I frequently will do that by mixing the 1/2 teaspoon of icing color in 1/2 cup of water, adding that to the dye bath, and then we'll go and dye our yarn. But since we want to do calculations today, I am going to dissolve it in a more defined volume. So say, for example, that we were to take our 1/2 teaspoon and dissolve it in 100 milliliters of water. To calculate how many milliliters of dye we need for any given project, we would take the number of grams of fiber times our desired, I suppose this is our desired DOS or on weight of goods, just defined slightly differently, our desired saturation, and divided by our concentration, which in this particular situation would be for however many milliliters of our dye stock we would need. We would take the number of grams of fiber, and then we would multiply that by this number here. So our saturation that we want is a half teaspoon of the icing color per 100 grams of fiber. The concentration is a half teaspoon of our icing color per 100 milliliters, which would give us, if we wanted to dye 100 grams of fiber, we would need 100 milliliters, which is consistent with I guess these numbers to begin with, because we know we want a half teaspoon of the color. We have a half teaspoon per 100 milliliters. We want a half teaspoon per 100 grams. We're going to use the whole 100 milliliters. Why bother doing these calculations when it comes to food coloring? I mean, what is the big deal here? Well, this can become a little more important if you want to dye something that isn't 100 grams. So say I wanted to dye 125 grams of yarn with the Wilton's Violet food coloring, and I wanted to keep those proportions the same. It would start to be harder for me to accurately measure with my measuring spoons these more complicated fractions of dye. So therefore, making a little stock and then measuring out a specific volume can be very, very helpful. So I talked about this with 100 grams, but say that I wanted to do the 20 gram miniskein. If I had my concentration at half a teaspoon of the food coloring per 100 mil, which I still have down here, I would need 20 milliliters. But what if I was going to change the concentration and dissolve the icing color in 200 milliliters, which would be a little bit less than 3/4 of a cup total volume? If I still wanted to dye 20 grams of fiber, now I would need 40 milliliters of our stock solution, because by dissolving the half teaspoon of Wilton's icing color in 200 milliliters of total volume, our dye stock is less concentrated, which means that we would want more of that volume to get the equivalent color. Once again, there is not a defined depth of shade sort of calibration when you're dealing with the food coloring. So I guess I'm going to be referring to this as levels of saturation, just so that way it's not as confusing, since the depth of shade refers to the grams of dye per 100 grams. And now we're talking about a volume. I don't really want to get too confusing. But if I'm calling the saturation level of 1 to be the typical level of saturation that I like. So anything that is a fraction or a decimal would be less saturated than what I normally do, and anything higher would be more saturated. So as we calculated previously, for my standard half teaspoon of Wilton's Violet food coloring per 100 grams saturation level, I would use 20 milliliters of our stock solution that had the half teaspoon per 100 milliliters, or 40 milliliters of the stock solution that had a half teaspoon per 200 milliliters. And if I wanted to double the level of saturation, I would use 80 mils. If I wanted to have half the level of saturation, I would use 20 mils. So the equivalence here would be a half teaspoon per 100 grams. This would be a 1/4 teaspoon, 100 grams. This would be 1/8 of a teaspoon per 100 grams, and then 1/16 teaspoon per 100 grams. And then finally this one would be 1 whole teaspoon per 100 grams. Maybe it would have made more sense for me to define this as 1 teaspoon, but I was hoping that just with these numbers I would make it clear that this is the level that I typically do. And so I wanted to sort of define it by that ratio. of what I aim for with this color. If we wanted to create a fade of Wilton's Violet, it is more accurate for us to make that stock solution and then measure out these volumes. As long as our stock is well mixed, it's more accurate to do that and then measure out these volumes than it would be to measure out each of these volumes independently, dissolve them separately, and go. Could we bring this back to grams instead of dealing with these volumes? Absolutely. However, it is fairly accurate to measure out the volume of a gel. Even if you aren't getting it completely level, there is a reproducibility there. And the reason why we use grams with powder dyes instead of the volume is that depending on a lot of other factors and how packed or fluffy it is, you could get really different results when you're looking at the volume versus when you're just looking at the absolute number of grams that you have there. I pre-measured the volume that this could hold and know that the level that I have now is below the 200 milliliters that I want. So now, well, I am going to measure approximately our ½ teaspoon of the Wilton's Violet food coloring and start stirring it in. And you could see that, you know, it's gloopy, and so it takes a lot of stirring. We're not completely dissolved yet, but I do want to add some more water volume. So I am going to measure out the first 100 milliliters using a graduated cylinder and pour that into a beaker. Now I am going to measure out, and oh, I was pretty close. I need about 30 more mils. But then I will be able to use that to help me dissolve what is left in here. Tiny bit at a time, stirring up, and then focus on making sure everything in our little stock is as well mixed as possible. So there we have it. We have a ½ teaspoon of Wilton's Violet food coloring dissolved in 200 milliliters. And now we can go aliquot this into some mason jars so that way we can start making our different levels of saturation of this color on some stock yarn. Today, I think the order of operations is going to be to start with ½ cup of water in each jar, add the dye, then I'm going to add the pre-soaked mini skeins, and then once I'm ready to go into the basket, then I will add some acid to each of the jars. All right, first we need 80 milliliters, then 40, and this 40 will give us the equivalent of 1/2 teaspoon per 100 grams, and so this is the one that is the concentration I use the most often. And then we have 20, 10 milliliters, and 5 milliliters. Starting with the least concentrated, I'm now going to mix these all up, make sure everything is well mixed in the jars. So going back in the reverse order, I'm adding 75 milliliters, 70 milliliters, 60 milliliters, and finally 40 milliliters. Now that they all have the same volume of water in them, I'm going to go ahead and add another ½ cup of water to each jar. The reason why I decided to add some more water to each of them is that I really wanted to make the visual difference between these different dilutions a little more obvious. I think if I were to backlight them, then you might be able to see the gradient a little more, but it might also be a little easier to tell once we add our yarn. Starting with the lightest color, I am going to add the yarn into the jar. And I'm starting with the lightest color because that way I can use a spoon to sort of press things down without really like messing up, like adding too much dye to one of them, to just make sure it's nice and saturated. And you can see just how much pink, even with no acid, these yarns are absorbing. So is this going to give us a dip dye gradient? No, of course not. We'll probably have some kettle dyed. I'm not sure how much breaking we'll necessarily see, since these are reasonably submerged in their respective jars, but there'll definitely be some different levels of saturation in here. How is that for a gradient? You can clearly see the difference in the level of saturation between each of these jars. And now, well, we still need to add acid, but we also need to heat them so that way we can set the color. Now I'm going to add 1 teaspoon of white vinegar to each of these jars. And once again, starting with the lightest color, sort of quickly. Whoa! Look how, oh right, I forgot that with acid, sometimes you see some shifts of color in the jar. But a lot of pinks have already absorbed, even without the presence of the acid. I placed these 5 1-quart mason jars inside my pasta insert in my dedicated dye pot. And I mean, some of them, like this one, already looks like it's mostly clear. But the most concentrated one still definitely has a lot of dye in there. And so we do need heat. I used about probably 14 or 15 cups of water to get the water level in the pasta insert just below the water level of the jars. And so effectively we've got a double boiler system here. And so I'm gonna let this go, I think, for 15 minutes, and then we'll check back in. I don't think we're quite at a boil yet, but check out our pretties. Is there color? Yeah, there's a little bit of blue left in our darkest. Rinse this off in the middle. Let's say the palest one has cleared for sure. There's still some blue in the secondary. Yeah. And, you know, again, we're not even at a boil yet, but you can very, very clearly, and let me fluff this yarn back up, clearly see that we have, you know, pastel through a very saturated purple. How much breaking is there? I can see a tiny amount where you can see some like shifts between more blue and less blue, but that'll be more obvious once we remove some of the yarn from these jars. But I am going to go ahead and let this cook for another 20 minutes. And then we'll decide if we need to up our vinegar concentration. One other thing to add is, can you do this without doing all this math and without doing all these calculations? And the answer is absolutely yes. If you want to make sure that you get a particular color on one of the minis, then calculations help. However, you can mix a stock and then do serial dilutions to get a progression from like really, really saturated to a pastel. I have a serial dilutions video that I'll link to, but it's basically you keep diluting the same thing over and over, and you end up with concentrations where each one has half the amount of dye as the previous one. And you can end up with something very, very much like this. So math can definitely help, but it is not the only way to achieve this kind of result. All right, we're definitely boiling now. And let's see. Okay, that looks clear to me. And ooh, that's a beautiful purple. So here is the equivalent of, I guess, our standard. I'm really liking this darker one though. Ooh, I see some breaking in there. Oh yeah, there's probably a lot more breaking in these paler ones. But anyway, I'm gonna turn off the heat and I'm gonna let this sit in here for a little bit. Let the jars cool enough so that way I can comfortably remove them. And then, yeah, we'll take a look at them. Oh, you guys, this is so beautiful. Oh, I love the way that these have come out, and I haven't even removed them from the jars yet. I'm now gonna use my tongs to help me pull them out, so that way they can finish cooling, and then we can go and wash them. Oh yeah, I see. Could be classified as breaking. Pretty subtle. These are definitely tonals, but that is in fact what we wanted. So the breaking that I see is very subtle. There are places that are more pink and more blue, but overall these are very much purple. The palest one is looking the most pink, but you do see like some more blue and pink patches in there. Whatever the colors are, this is a glorious fade set, and oof, it'll turn into something really beautiful. If you decide to go for something like this without calculations, you could run into problems in two different places. If you start with too little dye, you could end up with things that are also pale. It's hard to tell the difference between them. And likewise, if you start off with something way too saturated, the darkest colors, it could be hard to distinguish the difference between them. And so we ended up with a real perfect gradient where we can clearly, even when wet, see the difference. In Dyepot Weekly 117 with the black color, I wasn't sure if the darkest three shades were the same or not. Turns out you can tell the difference between them, but they are much closer together in the terms of depth of shade than, say, than these ones are. So one benefit of having a sense of, I guess, the level of saturation of a particular color can help you get a sense of where to start with. If you have a saturation level that you're really comfortable with, use that as a starting point so that way things don't end up too muted or too dark. My rule of thumb with acid dyes, start around 1% DOS, and with food coloring, starting with about a half teaspoon of food coloring color per 100 grams. With liquid drops, it can vary a little bit more between brands because some of them are way more concentrated than others. And at times, if we were, say, doing 1, 2, 4, 8, and 16 drops of color, maybe the one drop could even be super saturated on 20 grams. So you might end up wanting to make a stock solution so that way you can get something even more dilute than one drop. And that's something that I know I have done in the past. My point is that there are absolutely applications to make stock solutions with food coloring, but it all comes down to keep a diary, keep a notebook, and keep track of the amount of color that you use per yarn, even if you're not saving swatches. But knowing the levels of saturation that you like and the proportions that you really like can help you when you go to dye further projects. I'm feeling really amused right now because this is the gradient that I think some people might expect with dip dyeing purples, but that you could really only get something like this from using miniskeins, because since we know that the reds absorb before the blues, you're not going to be able to get this like pale pastel purple unless you dilute the dye in advance. I'm adding some clear dish soap, but I know that all of the color is in the yarn. So I'm now going to rinse out the soap put the yarn through my spin dryer and hang it up to dry. And I like to use a little nylon zip tie to help hold things together. So that way it's just one more tie. This way I won't tangle things. If you want to learn more about any of the supplies and things that I use in this video, you can find links in the video description. When we lay out the gradient of yarn, you can really appreciate some of the breaking that we see, especially in some of the darker colors where you can see either more blue and more pink patches. Dyeing yarn with purple food coloring is one of the hardest things to do because those reds were striking before we even added acid. And the blue strikes so much slower that instead of a more kettle dyed effect, you see these breaking of the hues, which of course is a property that I absolutely love and I love to take advantage of. This is the first time that we've gotten a gradient like this of all of these different shades of the actual Wilton's Violet food coloring. Instead of getting a more intense color breaking from a more fuchsia purple to this bright blue at the end. And this is something that we see with dip dyeing Wilton's Violet. And on the skein that I just laid out, I used half a teaspoon of Wilton's Violet food coloring per 100 grams of yarn, which is the same proportion that I was going for on this skein right here. And those colors are very different. The end looks deeper, but that's because it's dip dyed. So there's more, the colors are more concentrated on that end than they are on the blue end. But I just thought it would be fun to share that as a comparison. So the equivalents that we were looking at today were a half teaspoon of Wilton's Violet food coloring per 100 grams of yarn, 1 teaspoon, a quarter teaspoon, an eighth of a teaspoon, and a 1/16 of a teaspoon. Now, I showed all the calculations. We dissolved our half teaspoon of dye in 200 milliliters of water, and then from that concentration calculated how many milliliters of the stock we would need to get these equivalent levels of saturation on the yarn. And I did these calculations without saying like, oh, this is a 1% stock solution, or I want this percent depth of shade, because I wasn't dealing with grams of dye per volume of water. I was dealing with a volume of dye per volume of water. And so, and I'm sure I could have converted the teaspoon to milliliters and then done something with that to give it more of a number. But I think with food coloring, since there isn't a standard out there that I'm aware of, I think saying your concentration and including those units are a really helpful way to communicate it. Because if I say to you, I use a half teaspoon of Wilton's Violet icing color per 100 grams of yarn, you know what I mean and you know how to go and reproduce that. So overall, like all the calculations are consistent no matter what kind of dye you're using. It's just your units might change. And so could you do this in terms of grams? Sure, absolutely. You could weigh out your icing color and make a 1% stock solution. It's just, I wouldn't necessarily store a food coloring stock solution. I'm not sure how shelf stable that is, not in terms of spoiling, but in terms of the colors remaining dissolved. And so that's why my personal preference is to mix it fresh each time that I am going to be playing with it. And again, I really think that instead of the way I did it today in making the stock solution and calculating how many mils I should use for each color, it would be a lot easier to just do serial dilutions. Phew! I really, really hope that this was helpful, everyone. I am Rebecca from ChemKnits, and I love it when you guys make requests, especially when it's something that I have in my head and I was working on anyway. It sort of confirms that I'm on the right track with the content that I'm creating. Please always leave questions and comments on these videos because your suggestions really do make an impact on my filming schedule. And sometimes if there's something on my list, my very, very long list, it might get bumped up the queue depending on how many of you are asking questions about it. Don't forget to subscribe and like this video. Turn on notifications by tapping that bell icon because you really don't want to miss any new content. Finally, if you're a huge ChemKnits fan and really appreciate the content that I create and want to support it on another level, go and check out the ChemKnits Patreon. It's a way of subscribing to me and this content that I'm creating, and in exchange for your support, you get some really cool perks like early access to new videos, behind the scenes sneak peeks, and more. You can find a link in the video description and iCard, and you really should go check it out. Thank you so much for watching, everyone.